data. I'm going to give you a short stratigraphic section. We had some from the back and some going to the front. So if you've got it there, go to the front. Anyway, and so there's 2 pages. One is a strat column, and one is a description of outcrop units. And what I do over the next couple of weeks is guide you, and you're going to actually do it on your own with the data we're collecting, but I want to guide you through how you go from observation on an outcrop to interpretation of depositional environment. What kind of place was it deposited in? And so this is just to show you and make you feel less intimidated by gathering your own data. This is some actual data I gathered a week ago. And you can tell it's almost illegible because I am not the best writer or drawer in the world. But it's real, and if you start looking carefully, you will see all the stuff we've talked about. There is grain size, rounding, sorting. On this one, I didn't do much with rounding because it's like all subangular. There is bedding plane, bedding geometries, and overall outcrop geometries showing how beds relate to each other. There are contacts between units and beds and that are described, and there are sedimentary structures. And so anyway, so what you do when you on Friday start doing this, lay out your field notebook. And I usually lay mine out, so I like having, I'm left-handed, so I like having my strat column in the left. And you start with the base of your, actually, you know what you always start with is, where am I? Where is this section located? How do I know what's the base of the section? I can't remember if I included that on this one.
Base 4, section 1.
Yeah, base of section 1, station on map. Purplish gray plating. Oh no, that's unit 1. Then the previous page had the date, who I was with, how to get to the location, and how you recognize the start of the station. So I said September 12th, working with Josh and Claire on stratigraphic section 1, Josh Strat section 1. This is located on north side of hill where stream goes into canyon. And then because I'm not in Texas, I did section range township. You guys, did you ever learn that?
Mm-hmm.
Yeah. So it was like
the different coordinate mapping system.
You know, it was like section 34, township 17 north, range 48 west, Colorado datum, and then we started doing, and then I said, to find the bottom of this section, look for the lowest outcrop of gypsum cap rock exposed on the north side of this hill, da-da-da. And so I explained how to get there. And I was going to do those pages, but I was having copier issues this morning. And so then we start the section. So you start with, what am I doing? Where am I? How do I find this? How do I find the bottom of my section? I'm at the top of the hill, just above where there's a broken bicycle, where somebody went off a cliff. You know. Then, once you've done that, you start with section 1. And so I usually, it's either like in this section, I had a covered interval. So I had a bunch of dirt. Then I had a meter of stuff that was actually below what I was interested in exposed. And so you covered, so you start off section 1, base covered. And that is, and a lot of times, say contacts between things may be covered. So you can't see them, so you just say that. And so base covered, and then I described what it is. And it's a breccia. It's not a sedimentary breccia. It's a solution breccia. You had a whole bunch of nice salt and you dissolved it all, and now it's just all fallen into itself. And so it's this weird angular breccia of all this different stuff that's all kind of being glommed together. And the term we use for that is salt caprock, because you have a bunch of salt, it rains, the salt dissolves away, and you're left with the more insoluble pieces that we call a caprock, but it's just the stuff that didn't dissolve easily. And so that's what that first part is.
Mm-hmm.
And then we go into the description. If you notice at the top, what I do, and you don't have to do this, but I recommend it, is I make a scale, and I do clay, silt, and then very fine sand, medium sand, coarse sand, very coarse sand, granule, pebble, cobble, granule, pebble, cobble, boulder. And then I make my section go out there. So the first thing is a conglomerate coming up here, and it's a breccia. I think it was a breccia. Yeah. It's actually a coarse sand, I think, with breccia in it. So I make the edge of my outcrop come to here where my coarse sand is, and then I show what it looks like. Show sedimentary structure, show contacts. That was an erosional contact. I'll usually write erosional, or E for erosional on the side. And then here, I do that description, and that's the second description you guys will see. The first description is the breccia, because I went ahead and described it so I could tell this from this. But here's the first section I'm interested in. It's the first sedimentary one. Okay, questions?
Are we doing wind direction too?
What do you mean wind direction? Ah, that's not wind direction. That's paleocurrent direction. And that is something we will work on next week. It takes a little practice to do. Now that you guys know bed forms, you can, if you make I'm going to make a block here. That's a good question. You make a block showing bed forms. On the side, the trough, it's hard to do with some, but with dunes and ripples, it's usually pretty easy. I was doing it with both here. So here's a side view of a bunch of trough crossbeds, dunes. And, okay, those are kind of going that way, right? As it goes from top to bottom, it's going that way. So part of my direction is off to the right, whatever direction it is. But you cannot tell paleocurrent direction until you have a third dimension. Because is it going that way and out of the board? Is it going that way and into the board? We don't know. And so you need some hint of a third dimension. Like for these guys, maybe it's like this. And if I look at this in 3D, the top looks like that, and then this side looks like this. So those are going that way. And I will show you in the field how to do this. It's very hard to imagine from, and it actually takes a while in the field to learn how to do it. The best thing to do is actually get up on top of an outcrop, and then you can actually see directions, because you, oh yeah, there's my trough. It's going that way. It's relatively rare to do this. to see this, but you usually can get sort of breaks in an outcrop where it'll step over and go, you say, okay, yeah, it's going that way and that way. And then you have to sort of guess at the exact direction, but you can get a pretty good estimate within 5 degrees. That's why we round off. So you'll see there are paleocurrent directions there that are like, and I use little arrows to sort of, so I can get just a visual feel. And I also think did I have in my description, is this one of them? Yeah, see here we only had a couple. It says TR axes. That stands for trough axes. So I had 2 trough axes at the very bottom that I was able to measure. In the section above this, we had lots and lots of measurements, where we just found a really good place. So we measured about 7 or 8 of them, and those are, so you realize I'm not the best writer in the world. I wanted you though to be sure that you don't have to be too pretty at this stage. You just have to be able to clearly be able to read your own stuff, say 5 years down the line when you come back to this and go, I can do that. I can read my own stuff 5 years down the line. So any questions? So everybody see how this works? And we're out of time. Okay, well, then what I will do on Friday is Dr. Pavlis wants in-class things. So we are going into the field on Friday. Dr. Pavlis wants you in class, so we'll also do this class. And in class on Friday, I will remember to bring my laptop so we can